Good morning, everybody. Hope you're all okay. Welcome to Friday. We've made it to the end of the week. So let's get started with our Fab 4. So today we're going to use known facts to help us to multiply whole numbers by decimal numbers. So we know that 6 times 9 is 54. So you've got 4 minutes to have a think how you might use that fact to calculate the following 4 questions. So pause the video, come back when you've got some answers. All right, so well done. You've obviously had a go at calculating. Let's see how we've got on. Now, the first couple of questions, either the 6 or the 9 have been made 10 times smaller. So the 54 have got 10 times smaller. Question number 3, 0.09 is actually 100 times smaller than 9. So our answer is 100 times smaller. So hopefully you've been able to relate the difference in the sizes of the numbers to how your answer changes each time. The final question, each of the 6 and the 9 have been made 10 times smaller. Therefore, our final answer is 100 times smaller because we've put those two together. Now, for our main lesson today, we're looking at writing decimals as fractions. We're going to be able to interpret fraction diagrams and how to read them as a fraction and a decimal. And we're going to find equivalents as tenths, hundredths, or thousandths. So for our discover, we've got Mr. Jones, and he has got 3 diagrams here showing different fractions of the diagrams that have been shaded. He's currently written them as a decimal number, and you can see Ivo and Isla holding the fraction cards underneath, and they're trying to decide which fraction card matches to each diagram. So we're going to have a look how we're going to decide which fraction cards are equivalent to the diagrams. I'm going to look at them one at a time. So here's our first one. You can see on the right hand side is the picture, the diagram that we've just seen of the amount shaded of a chart. And then we've got our place value grid next to it showing it as a decimal number. Now, if we look at the place value grid first of all, we can see it says 6 tenths. Therefore, we know how to write that as a fraction, don't we? Because 6 tenths looks like that. There's 6 in the tenths column, therefore the fraction is 6 tenths. Now looking at the grid that has been shaded, there are 10 parts to that grid, which tells us the denominator, and the number shaded is the 6, and that is the numerator. Simple as that. So in this case, our place value grid, this time we have nothing in the tenths, but we have 6 hundredths. Now if we look at our chart that's been shaded in this time, you can see it's actually divided into 100 squares, and of those 100 squares 6 have been shaded. Now that means our denominator this time is 100 because there's 100 squares. The number being shaded is 6 again, so we would write this as a fraction as 6 hundredths. Now it's very obvious really when we look at our place value grid, because in our hundredths column there are 6. That means we write 6 over 100. So hopefully you can start to see the relationship between the decimals, how we get from that decimal to our fraction. Now this one's a bit more of a strain on our eyes because the chart that's been drawn this time has actually been divided into 1,000 squares, which is very difficult for us to see. But we've got 6 of those have been shaded. Now our place value grid, we can see that we've got 6 thousandths this time. Always a funny word to say, shaded. So that means that this time we're going to have a fraction of 6 out of the 1,000 have been shaded. So our denominator is 1,000 and our numerator is 6. Now we want to know how to make this into an equivalent fraction so we can compare these fractions, because sometimes we might be asked which of these is the largest fraction. Now often we might be able to use common sense to figure out that, but we need to have a mathematical explanation. Now in order to compare them, our denominators need to be the same. So if we look at the first one to begin with, 6 tenths, and we want to compare it to the 6 100ths, we can actually convert, can't we, our 6 tenths into hundredths. So how would we do that? Well, we think, well, to go from 10 into 100, we're going to multiply by 10. So we do the same to the bottom of the fraction and the top. So we would get 60 100ths. But that means that 60 100ths is the same or the equivalent to 6 tenths. So now I know that actually 6 tenths is a larger fraction than 6 100ths. Same for the next one. If I then thought, well, look at the bottom one where I've got 6 1,000ths. How can I compare my top grid to that? I could just put it into thousandths because it is a number that can multiply from 100 into 1,000. So I can see that 6/10 is the same as or equivalent to 60 100ths, which is equivalent to 600 thousandths. I've multiplied by 10 each time. So now I can compare this fraction or decimal to the next two on the slide. Now, if I wanted to then compare the second one, the 6 100ths to 6 thousandths, I could just put that into thousandths. If I multiply by the top and the bottom by 10, I could see that I could get 61 thousandths. So I can from there then think about this. How can I order the fractions onto a number line? Now, as soon as they have a same denominator, we can do that. So here's our fractions. Now, in order to make them all have the same denominator, we needed to change them into thousandths. So here were their equivalent fractions for thousandths. Now we'd have to think, right, how am I going to decide where to put them on the number line? The number line starts at 0 and goes up to 1. So really, if I wanted to put all the little lines for this, I'd need 1,000 lines, which would take me all day. It would be a bit of a wasted task. So this is where we have to use our estimation. And what we're going to think about is the relative places of things on that line. Now, 600 out of 1,000 or 600 thousandths is just over halfway, isn't it? Because halfway would be 500 thousandths. So I think that really, if we were looking at 6/10, we'd go about here. It's just beyond halfway, because I know that 500 thousandths or 5/10 would be halfway. Now then, 600ths or 61 thousandths, that's just a little bit lower, isn't it, than 100,000. So I could, if I had my pen here, divide my line into 100s until I got up to 1, and then I would be able to think, well, 6 100s would be about here. Now then, 6 1,000 is even smaller, so that's got to go before it. So I'm not trying to be exact with where I'm plotting these, but it's helped me to get an idea where they are in relation to each other on a number line, and that helps us to realise the size of those fractions. All right then, now the next part of our discover, oh, my head is in the way again, wants to know which fractions can you simplify. Now, if you remember, simplifying is when we make our fractions as small as possible. So we've said that 0.6 is the same as 6/10. Now we can halve both of those because they're both in the 2 times table, which is the same as 3/5. So 0.6 in its simplest form is 3/5. You've got 2 jobs to do. You've got to put it into its fraction tenths, and then can I simplify it? The same for this one. So this was 6/100ths. So that was my first fraction. Now I'm going to simplify, and that would go down to 3/50ths. And the final one, 6,000ths. Now they can both be divided by 2, and so that would make 3/500ths. So there you're making them into their simplest form, which is obviously different to when we were looking at equivalent fractions. Now then, we're looking now at these decimals, and we want to put them on the number line as fractions. Okay, so when I'm doing this job, what I want to do is, first of all, I've got to think, how am I going to change my decimal numbers into a fraction? So let's have a little look. 0.1 has been done for us, and they've said that that is 1/10, because we know that that's in the tenths column. What about 0.25? Think about what we just looked at with the previous ones. How is this going to look as a fraction? Now, it's not going to be tenths, is it? Because there's something now in the hundredths column. So if you've got 2 digits after the decimal point, you're looking to the furthest one away to decide what that fraction is going to be over, what the denominator is going to be. Now, because we've got 500ths as well as 2/10, it means it's got to be over 100. So in this case, it's going to be 25/100ths. It wouldn't make sense for it to be 25/10 because you would have just forgotten that hundredths column. Now 0.6 has only got something in the tenths column, so that's going to be 6/10. And 0.85, what do you think? Have a look at the 0.25. Can you work out what that would be as a fraction? It's going to be 85/100ths. Now from there, you could decide I can order the fractions, or can you? Can I at the moment order those fractions? I can't, can I? Because my denominators are different. So what I could do is think, well, some of them are out of 100, some of them are out of 10. So let's put them all over 100. Let's make them all into hundreds. So 1/10 would become 10 hundredths. 6/10 would become 60 hundredths. Now, because their denominators are all the same, I can just think, well, 6/10 is the, sorry, no, I'm looking at it in the wrong one. 10 hundredths is my smallest, so 0.1 would come first on my number line. Then I've got 25 hundredths, which would come next, 60 hundredths, and then 85 hundredths. And you can look at where they might fall on that number line carefully. Let's do the same for this one. So it wants to know how would we change these into fractions. So 0.92 has been done for you, is 92 over 100. So what will 0.95 be? What do you think? It's going to be 95 hundredths, isn't it? Oh, now look at the next one, 0.975. Now, we've gone beyond the hundredths column. We've got a 5 in the thousandths column. So what will the denominator be this time? It's got to be thousands, hasn't it? Because otherwise it would be too small. So here we've got 975 thousandths. Now, if I wanted to plot these, they've been done for us, but if I wanted to plot them, the easiest thing to do would be to make them all over 1,000. So 92 hundredths would become 920 thousandths, and 95 hundredths would become 950 thousandths. It's quite a lot to take in today, isn't there? Lots of different steps, but don't worry, you can keep going back over the video if you need to whilst you're going through your Power Maths books. Now this is the final bit, and let's hope we don't get too confused here. So this time we're looking at diagrams, and they want us to be able to put mixed numbers into fractions and improper fractions as well as a decimal. So I've got 2.3 on this bar chart, and it's shown that the 2.3 is made up of 2 wholes and 0.3. So really we can do that. We know that 2 wholes, 0.3. What 0.3 is a fraction? Well, there's 3 in the tenths column, so it's going to be 2 wholes and 3 tenths, which looks like that, 2 and 3 tenths, just as we've seen it before. So that is 2 and 3 tenths, but just written as a decimal. Now, how can we change that into an improper fraction? We did loads of this before Christmas. Who can remember what to do? We have to multiply our whole number by our denominator and then add our numerator, which gives us 23 tenths. All right, hope everyone's keeping up. Next one, so here we're back to our place value chart where we've got 2.53, very similar to the previous one. We've got 2 in the ones column, which means we've got 2 wholes, and this time we've got 5.53 after our decimal point, which means it's got to be over 100, hasn't it? Because our final digit is in the hundredths column. So this time we've got 2 and 53 hundredths, which looks like that. Again, can you have a go at putting it into an improper fraction? Multiply your whole number by your denominator and add your numerator, which will give us 253 hundredths. Final one, here we go. This is the hardest one, I think, on the number line. Now, on our number line, we're looking at, can we decide what this is going up in? I looked at this and thought, oh, this is really complicated. So it starts at 2.5, goes up to 2.51. So it's starting just in tenths, and then it goes up to hundredths. So what on earth is this going up in? I must be going into my thousandths column. And actually, it's going up in 1,000 thousandths, can't say it very well, at a time. So 2.501, 2.502, 2.503, and so on, all the way up to 2.509 until I get to 2.510, or 2.5, looks like 2.510 when we're thinking in our thousands. And that's where we get to our 2.51. So then the arrow is pointing at 2 and 503 thousandths, which looks like this as a fraction. Nice big chunky number. Please don't worry if this has got you completely bamboozled. This end is more in your challenge. So if this is too far, then please don't worry, you can always message and ask for some help. And final step for here is putting it into an improper fraction, which gives us 2,503 thousandths. Wow, that's hurt my brain a little bit for Friday morning. So it's your turn now. Page 12 and 14 is the third lesson in your Power Maths books. Have a go. Remember to keep using the video if you need to go back over anything, or just send me a message and I will help you as best I can through the message chat on Dojo. Have a great day. Good luck, and I'll see you all on Monday. All right, bye-bye.